In this video, we'll talk about inverse trigonometric functions. First, let's look at the inverse function of sine, that is usually written as arcsine x. Sometimes you see it is also denoted by sine -1x. -1 is the universal notation to represent the inverse of a function. Okay, let's see how this inverse of sine is defined. First, let's recall the graph of sine x, sine function. To avoid confusion, here I use the variable theta. It's the horizontal axis, and this is the graph of sine theta. Now, as a whole, we know the sine function is R function. It's 2 pi periodic. The values change from -1 to 1. Now, of course, if you just look at the whole function, the function is not increasing or decreasing. Nevertheless, if we look at the restriction of value between -2 to pi/2, then the graph of the function is strictly increasing, and it covers the whole range from -1 to 1. Therefore, within this range, from -pi/2 to pi/2, we can define the inverse of the sine function. Okay, so the way we do is, let's say I pick x here, right? So that's the value of the sine, and then all we need to do is we find the corresponding angle theta here, such that the sine theta equals x. So what we want is the x equals sine theta, and then theta is defined as the inverse, which is right as the arcsine x. Okay, let me write down and repeat the definition here. Okay, so what's the definition? We say theta equals arcsine x. Now, x is the value of the sine function that, of course, is between -1 and 1. Right, so for x belongs to the interval -1 to 1, we say theta equals the inverse function arcsine x. Means, number one, if the following two things hold. Number one, we need the x equals sine theta. Of course, this is not enough because the infinite many theta will give us the same sine value. We need to restrict the range of theta. It's between -pi/2 to pi/2, and we need theta belongs to -pi/2 to pi/2. Given these two restrictions, the theta is uniquely given. For example, let's go here. We have, if I have, say, it's sine 1, then it's the value is sine, it's the angle, the value of the sine is 1, within -pi to pi/2, then we know, of course, it's just pi/2. This one equals pi/2. Then how about sine, say negative the square root 2/2, which is right here. This is the negative the square root 2/2. If we look at corresponding angle within this range, and we have is -pi/4. So this one equals -pi/4. Now, of course, if you look at the arcsine 0, then it's just the angle 0. Similarly, we can define the inverse of cosine function, which is usually written as arccosine x. Sometimes it's cosine -1x. Alright, so let's see how it is defined. If you recall the graph of the cosine function, so again, here I use theta to avoid confusions. As a whole, the cosine function is an even function, right? Symmetric with respect to the y-axis. If the value changes from -1 to 1, the function is 2 pi periodic. However, if we restrict the cosine between 0 to pi, right, within this range, from 0 to pi, and then we see the graph, the function cosine theta, is strictly decreasing. Therefore, if I pick an x here, let's say I pick x here, I can find only one within this range from 0 to pi. I can only find one angle theta, let's say it right here, the theta, such that I have the x equals cosine theta. Equals cosine theta. And this theta is defined to be the inverse value of cosine. It's written as arc cosine x. So by definition, we have definition theta equals arc cosine x if it satisfies two things. Number one, we need x equals cosine theta. Now this is not enough. We need to make sure theta is within the range from 0 to pi. So and theta belongs to 0 to pi. X is from -1 to 1. For example, if I want to calculate, say, arc cosine 0, right? Okay, so when it's attained 0, then the angle is pi over 2. This is pi over 2. Then let's see arc cosine -1/2. Well, cosine -1/2, we have this right here. So this is -1/2. And then we find the corresponding angle, which is bigger than pi over 2, bigger than pi. We know this angle is 2 pi over 3. Okay, so add up arc cosine -1/2 is 2 pi over 3. Also, let's do two more examples. We have the arc cosine 0, or arc cosine 1, right? 1, which is 0, right? Cosine 0 is 1 and 0 is between 0 and pi. And we can say arc cosine 1/2, right? Arc cosine 1/2, then this would just be pi over 3. It's right here. So I choose 1/2. It is pi over 3. Now let's look at an example. This is past the AMC12 problem. The question asks for how many values x between 0 and pi we have this equation. It says sine inverse, or we call arcsin, sine 6x equals cosine inverse evaluated at cosine x. Okay, let's first simplify this equation. Let's look at the right hand side. If say this one equals theta, then by definition, we should have the cosine, by the definition of arc cosine, I would say cosine inverse, cosine theta equals cosine x, and we need the restriction, the theta, the value of cosine inverse, the theta has to be between 0 and pi. Okay, here we already know the x itself belongs to 0 and pi. Therefore, the theta just equals x. Okay, so we get this one equals x. Okay, by this we have simplified the equation to sine inverse sine 6x equals x. Now, let's recall the sine inverse, right? The range of values of sine inverse, I would say arcsin. This one belongs to, by definition, is from -pi over 2 to pi over 2. If you combine the x is between 0 to pi, and then also we know this one from -pi over 2 to pi over 2. From here we get the x has to be between 0 to pi over 2. Alright, and then by the definition of the arcsin or sine, this just means sine 6x equals sine x. That is from the definition of arcsin. Alright, now if we know sine alpha equals sine beta, then the relation between alpha and beta is, this implies either alpha equals beta plus any integer multiple of 2 pi, or alpha equals pi minus theta and plus any integer multiple of pi, right? So here k always means an integer. Okay, now consider our range of x is from 0 to power 2, and then from here we get the 6x is between 0 to 3 pi. Therefore, what we can have from here, we deduce either 6x equals x, or we have 6x equals x plus 2 pi, or we can have 6x equals pi minus x, and the last situation is 6x equals 3 pi minus x. Okay, from here we just get x equals 0. From here we get x equals 2 pi over 5, and here we get the x equals pi over 7. The last one implies the x equals 3 pi over 7. Now let's double check whether these four are within 0 to pi over 2. Yeah, so these 0, 2 pi over 5, pi over 7, 3 pi over 7, they are all within the range from 0 to pi over 2. Therefore, all these four are valid. We have 1, 2, 3, 4. The answer is there are 4 valid x between 0 and pi which satisfy this equation. Now let's see the inverse functions of tangent and cotangent. First, let's look at the tangent. The inverse function of tangent. To avoid confusion, again we use a theta to represent the input for the tangent function. Alright, so if we restrict the domain of theta to be between negative pi over 2 to pi over 2, we know the tangent function is strictly increasing, and it covers the whole range of values of tangent. That's a collection of all real numbers. Therefore, we can define the inverse value. Say I pick the value x here, and then we find the corresponding theta such that their tangent theta equals x. Now, if we leave the range from negative pi over 2 and pi over 2, there's only one theta with the given tangent value. And for this theta, we just write as the arctangent theta, arctangent x. X. Okay, now by definition, so this is the definition. If we have the x, if we have a theta, so x is all real number. If I have theta equals arctangent x, or we write as the tangent inverse x. Either way is fine. Alright, this just means if the following two things hold. Number one, I have the x equals tangent theta. Of course, this is not enough. We need to specify the range of theta. Number two, we need to have the theta is belongs to from negative pi over 2 to pi over 2. Here is the open interval because tangent theta is not defined on pi over 2 to negative pi over 2. Those are called asymptotes of the tangent function. Now, given this definition, then we'll have the arc. Clearly, we have the arc. Tangent 0 is just 0, right? It's tangent 0 is 0. Then we have the arc. Tangent 1 just be pi over 4. And arc tangent negative 1 will be just negative pi over 4. Now, let's look at the inverse function for cotangent function. Here, again, we use theta to represent the input for cotangent. If we restrict the domain of theta between 0 to pi, cotangent function is strictly decreasing, and it also covers the whole range of values of cotangent function, which is the collection of all real numbers. Therefore, like what we did for the other functions, we can define the inverse function. Say I pick a value x, and then I find the corresponding angle theta such that cotangent theta equals x, and then this theta is defined to be the inverse value of cotangent. So theta is arccotangent x. Now if we restrict to the domain from 0 to pi, there's only one theta with the given cotangent value. Alright, so then this is the definition. We say theta equals arc cotangent x for any real number x. We define the inverse cotangent function, which also could be written as cotangent inverse x. If the following two things hold: number one, cotangent x equals cotangent theta. Number two, and when you specify the range of theta, theta belongs to 0 to pi. Again, here is open interval because cotangent is not defined on 0 and pi. Those two vertical lines are called asymptotes. Alright, so given this definition, we can have arc cotangent 0, which is pi over 2. And similarly, we have arc cotangent, say 1, this is pi over 4. Or we have arc cotangent, say negative the square of 3, this is 5 pi over 6. Let's look at an example. This is past the AIME question. It asks to find the positive integer n such that arctangent 1/3 plus arctangent 1/4 plus arctangent 1/5 plus arctangent 1 of n equals pi over 4. Okay, so here we have 4 angles. Let's denote this one as angle A, this is angle B, this is angle C, this is angle D. They are provided, given by inverse of tangent functions. Therefore, by definition, I have the tangent A equals 1/3, I have the tangent B equals 1/4, and then we have the tangent C equals 1/5, and tangent D equals 1 of n. What do we want? Right? What do we want? Solution. What do we need is we need to have A plus B plus C plus D equals pi over 4. Now, because we know there are tangent values, it's natural to take the tangent on both sides. From here, I get the tangent A plus B plus C plus D equals 1. Okay, now it looks like we need to use the sum formula for a tangent function, and there's indeed a formula which tells us how we calculate the tangent value of the sum of 4 angles, but that is hard to memorize. Instead of use that formula, we just use the basic one that tells us how we calculate the tangent value of the sum of 2 angles. So let's recall that formula. We have the tangent alpha plus beta equals tangent alpha plus tangent beta, and 1 minus tangent alpha minus tangent beta. Alright, so here I have 4 angles. I can consider, let's say this one, put this one as the alpha, and this, let's say, is the beta, right? And then we can do one by one. So this one equals, so this implies I have the tangent A plus B plus C plus the tangent D, 1 minus tangent A plus B plus C times tangent D, which equals 1. Now tangent D, we already know it's 1 over n. That's what we need to figure out. So I already know this guy is equals 1 over n, and this one is 1 over n. Therefore, all I need to do is to figure out tangent A plus B, tangent A plus B plus C. Alright, for that we just repeatedly use the formula. I have the tangent A plus B plus C. Now I can group A plus B first, and then go with the C. Repeatedly apply the sum formula. This one equals tangent A plus B plus tangent C, and 1 minus tangent A plus B and times tangent C. Okay, we know the tangent C. The tangent C equals 1 over 5. This one is 1 over 5. Therefore, accordingly, we just need to figure out what is the tangent A plus B, tangent a plus b. And for that, again, we just use the sum formula. Let's see. So we have the tangent a plus b equals, so everything here, from this step, I have this, use this sum formula. From here, I use the sum formula. Again, I use the sum formula. This one equals tangent a plus tangent b, and 1 minus tangent a times tangent b. Okay, now we have both tangent a and tangent b are given. This is 1/3, this is 1/4, this is 1/3, and this is 1/4. And then it's easy to calculate. We get this one equals 7/11. And then, after we get a 7/11, we can put right here to get tangent a plus b plus c. This one I replace by 7/11. And this is 7/11. You get this one is 23/24. And after you get 23/24, we put it back into here. And we just solve the equation for n. And it's not hard to derive. Finally, we just get the n equals 47. So for this problem, the two key ingredients. Number one, we just need to know the definition of arctangent. It just means the tangent value is tangent A is 1/3, tangent B is 1/4, this is 1/5, 1/n. And then we just repeatedly use the sum formula for the tangent function. Let's look at one more example. Here, what we need to do is to find a real number x such that arctangent x equals arccosine x. Okay, so first of all, by the definition of arccosine and arctangent, by arccosine, this angle has to be between 0 and pi. Arctangent, this one belongs to from negative pi over 2 and to pi over 2. Therefore, if I let theta equals, denote arctangent x equals arccosine x. If I combine these two ranges together, I immediately get my theta. It belongs to from 0 to pi over 2. Okay, now by definition of arctangent and arccosine, I get theta equals tangent theta. I get x equals, from here, I get x equals, that's from that, equals tangent theta. And from this, I get x also equals cosine theta. Now, okay, and they are equal. Both of them are equal to x. Okay, now, because theta is between 0 to pi over 2, and if x equals cosine theta, we know sine theta has to be positive, right? From here, I can derive my sine theta is equal to 1 minus x squared. That's because cosine theta and sine theta, the sum of the squares is always 1. And then I deduce the tangent theta shall be, just based on this piece of information, shall be the square root of 1 minus x squared and over x. And meanwhile, I have x equals tangent theta. Therefore, I get an equation which is x equals the square root of x squared minus 1 equals x. Alright, so from here we deduce the x equals x, the square root of 1 minus x squared. And then we multiply x on both sides and take the square. I get x to the 4 and plus x squared minus 1 equals 0. Alright, so x to the 4 is just x squared and squared. Okay, now if we consider x squared as one variable, right? So I consider this as the y and this is y squared. We can use the quadratic formula. I get x squared. X squared has to be non-negative. So this is 2. It's square root of 5 and minus 1. Alright, now also I know the x is theta is between 0 to pi over 2. X is cosine theta. So from here I get the x is non-negative. That's due to the range of theta. Alright, so combine all those things together. From here I just deduce the value of x shall be the square root of square root of 5 minus 1 over 2. we should choose the positive one.